In this video, we're still looking at integration by parts. We're just looking at when we have limits in place, so it is a definite integral. Okay, it says in this example, find the exact value of the integral between 0 and pi of x sine x. So just to reiterate something we said before, calculus involving trig has to be, the limits have to be in radians. You have to be using radians. So 0 and pi is going to be a radians number. So here we've got our integral. We're just going to say you're going to let your u be equal to x. That means your du by dx is equal to 1. Your dv by dx is equal to sine x. If you integrate sine x, you will get minus cos. And then we're good to go. So your integral, is equal to, so I'm just going to write it down. It is your uv. So we've got it up here even. We can just say it's uv. And the limits are BA. So here, this part, the UV has been integrated. That's why it's square brackets, and your limits, the B and the A, are to the right hand side. This bit is still to be integrated. That's why you put your integration sign, and your limits are here. So we can just go ahead with that. We use square brackets. This is our, we'll put it in here for the sake of it, integral UV, and that's between pi and 0 in this case, minus the integral between 0 and pi, I should say, and that's going to be my v du by dx integrated with respect to x. So just fill this in. So my u was equal to x, my v was minus cos x, so that's minus x cos x, and that's between 0 and pi, and then it's going to be minus, and then the integral from 0 to pi of v, which was minus cos x, times my du by dx, which is 1, so that's just minus cos x dx. Okay, the next step I'm going to do is a step that people, for some reason, very rarely put in. Now, this step will save you an awful lot of time. Now, what I'm going to do is I'm actually going to put in these things. What a lot of people do is they work through to the very end before they actually work anything out. This bit has been integrated. It more often than not will save you a lot of time to put these values in. It'll save you a lot of time writing this out. So we're just going to sort this out. First bit, we had put in the pi. You'll have minus pi times cos pi, and then that's going to be minus of minus 0, so it doesn't matter what it is. And then the integral then was minus minus, we'll make it a plus, so plus the integral of cos x dx, and that's between 0 and pi. Okay, I have a run out of space here. I'll just go on up to the top and finish this off. So this is me just sorting this out. We had minus pi cos pi. Cos pi would be minus 1. So minus pi times minus 1 would be positive pi. So the time that saves you writing that out, I'm just going to sort that out. Show all my steps here. Doing a wee bit more than I need to maybe. But the time that saves you, it's an unbelievable amount of time it saves you, because a lot of people will write that out every single line, keep writing it out until the very end. But just work it out. It's been integrated, get it as a value, and quite often, in fact, this bit ends up being 0, so you don't even need to write it at all. Okay, so we'll just go on and we're going to do our integration. We've still got the pi. If you integrate cos, you will get sine. So that's going to be sine x. That's now integrated. And you've got your limits, which are pi and 0. So that's going to be pi plus first square bracket is sine of pi, minus your second square bracket is sine of 0. Sine of pi is 0. Sine of 0 is 0. So what you're actually left with is just pi. And that's it. Okay, you're now ready to do topic 7, integration B, exercise 6, the same exercise as you were doing in the last one, I think it was indeed, but this time it's questions 3 and 4, which are definite integration.